Well, good day to everyone and welcome to Fluke Reliability's Best Practice Webinars. Today's session is entitled Why We Can't Proceduralize Everything and a Real World Alternative with Jake M. You guys can say his name. We'll let him say that in a little bit. We will get started in a few minutes. I want to give our folks a couple more 35 seconds to pile in. So stick with us. We will be ready to roll in 35 seconds. Well, fantastic. And once again, welcome everyone to Fluke Reliability's Best Practice webinar series. Today's session is titled Why We Can't Proceduralize Everything and a Real World Alternative. Today's guest speaker is Jake M. He will be introducing himself in a moment, but I just want to remind everyone to make sure that on your control panel, in your upper right-hand corner there, or wherever you place it on your screen, you'll see the gray bars that say chat. We have a chat feature there, but we do encourage that you use the question area for Q&A. So today, a little bit different, team. We're going to be taking all questions at the end. There's a lot of content today, and so we're going to just kind of wait till the end. But please do feel free to add your questions and comments in the Q&A section during the entire presentation. We'll read those to Jake toward the end, and if we don't get to your question, we will make sure that we answer live. We'll make sure that we answer it one-on-one. So, and the other thing too today, we're going to be doing polls a little bit different. So make sure that you have your phone near you because we're going to scan codes and have a little bit of a different procedure today. So without further ado, we once again welcome Jake M. to our Best Practice webinar series, and enjoy, take great notes, and please make sure you add your questions. Welcome, Jake.
Thanks, Dawn. Welcome, everybody. Thanks for joining us today. If you have talked with me or worked with me before, it's nice to meet you again, or see you again, as it were. And if we've never worked before, you're going to be in for something interesting today. This is going to be a fairly different perspective. I work in the world of human reliability as opposed to mechanical reliability, sometimes called human performance improvement. It's the idea of how do we help reduce errors among humans and organizations? And it's not simply about mechanical things, but actually reducing errors in teams as well. And not just reducing errors, but building reliability and something called resilience as well. What I'm going to show you today is something that's been a very popular module in some of the workshops that I teach. So let's just go ahead and get into it. A quick bit about my background. Sorry, I've been an advisor since about 2015. I tend to work primarily with scientific labs, Argonne Lab, Fermi Lab, things like that, some biotech labs, and also with electric power utilities. I spent about 10 years in an electric power utility in their safety and training division, doing the stuff that I'm going to teach you now, or at least the beginnings of it. It was about reducing human errors. So you can see a little bit more about my background there, and if you want more, go to my website, is reliableorg.com. Lots of content today. Let's go. We're going to start off with a story, and this story basically takes us to a NICU, a neonatal intensive care unit, several years ago. And the characters in this story, well, there's three of them. There's Melissa. Now she's a preemie, premature baby, born premature in a NICU, and two other characters. Linda is the nurse who is taking care of Melissa, and the third character in the story is Darlene. She's the charge nurse, or the supervisor. Now Darlene doesn't do patient care. She does supervising, budgeting, hiring, onboarding, mentoring, managing, things like that, but she misses the time that she used to take care of the little preemie babies. And so on this particular evening, it's about 1 o'clock in the morning, late evening or very, very early morning, Darlene is walking around doing some supervising, and Linda is taking care of Melissa and several other babies. Everything's very quiet in the NICU. Darlene walks past the isolette, which is what they call the things they keep the little kids in, and notices something about Melissa. Now, no one particular thing jumps out as this is wrong. In fact, Linda, the nurse who's taking care of Melissa, is doing great, doing everything by the book, following all the procedures. But Darlene has years, decades of experience. And she said later, something struck me as off, but I didn't know what it was. And so she looked at, for example, the heel, Melissa's heel, and there was the Band-Aid on the heel where they drew some blood and a little spot of blood on the heel. That's not unusual. It happens. It's where they draw blood, so that's okay by itself. There was a little bit of mottling on the skin on the stomach, and that in itself, not unusual as digestive systems kind of evolve and grow. And so something happened then. Darlene said, Linda's doing all the procedures right, but something is not right with Melissa. And so she goes up to Linda and says, hey, Linda, has Melissa been lethargic lately, overly sleepy or tired? And Linda says, well, kind of now that you mention it, yeah, it's within limits, nothing that would trigger an alarm by itself, but yeah, a little bit more than usual. And Darlene says, okay, something's wrong. Call up Dr. Bao and ask her to okay a sepsis test right now. Back then, sepsis, well, still today, sepsis is an infection that goes throughout your bloodstream and can reach every point in your body. And it's one of the biggest killers of kids in the NICU. And it takes hold pretty slowly. And if it gets ahead of you, you're in bad shape. But if you can catch sepsis early, in the early stages, and give antibiotics, you can get it. But you got to catch it early. And the test takes a little while to run. And so Darlene turned out to have been right. When the test came back, Melissa was indeed in the early stages of sepsis. Noticed something not with a mechanical system that was going wrong, but sensed what they call a constellation of symptoms that were really subtle and that were not covered in any procedure. And Darlene, because she was an expert, was able to literally save a life, not because she was following a procedure, but because she was doing something else. What else did she do? In the next 50 minutes or so, you're going to learn what. So, procedures. We use the term all the time. Let's go ahead and define it. It's a particular way of accomplishing something or a series of steps followed in a definite order. That's what I like. I like the second definition better. It's more concrete. So a procedure is a series of steps that you follow in a definite order. You all, I'm sure, live in the world of procedures. So I'm curious to hear what you think. So let's see, Dawn, if you wouldn't mind dropping that first link into the chat thread, the one that looks just like the one there. And folks, if you haven't already done it, go ahead and pull up your phone. If you've got an iPhone, it's real simple. Pull up the camera and just scan that QR code. Hopefully you've done this a lot of times before. Restaurants are doing menus this way, stuff like that. And it should pull up this, this poll. And go ahead and answer the poll. It's all anonymous, of course. And here's the cool thing. We get to show you the data live. Hopefully everybody has scanned the QR code. Thank you for putting that in. That's great. And let's see what responses are coming up. We should be getting a bunch of responses. And if not, then something's wrong, but we'll work around that. There we go. Okay. 1, 2 response, and let's see, we've got 104 people attending today. Not everybody's going to be able to join in or may not want to, and that's fine, but it would be great to get, let's say 80 or so responses. And I'll give a little bit of extra time because this is the first one of these polls that we're doing this way. We've got 4 polls like this, so keep your phone out and warmed up because a couple of other polls are coming. So 13, 14, 15, let's see. And this one does have several questions on it. So this is the longest of all the polls. Probably shouldn't have put that first. That's a note for next time. Okay, but the responses coming in say, let's see, 64% of people are saying, yeah, the procedures I use at work are generally accurate, up to date, and helpful. But that means 40% of people, 41, 42 now, are saying, no, that's not true. So now I or other end users like me, we get substantial input on creating the work procedures that we have to use. And that's great to see. 78, 79% of people saying yes, 21 saying not so much. The amount of procedures, that my boss expects me to use is reasonable. Pretty easy cut here. 2/3 say yes, 1/3 say no. And I'm assuming that the people who are in the red here are thinking there's too many procedures. But if not, let me know. Number 4, my company respects the use of rules of thumb or guidelines, principles, and tacit skill when appropriate. They understand that procedures are not the only solution. We got a good 60% say yes, but a big chunk, 40%, are saying no. And the 5th one, again, getting the red group is getting bigger and bigger for each question. My organization could benefit from using fewer procedures and more rules of thumb, guidelines, principles, and tacit skill when that's appropriate. And it isn't always, but sometimes it is. And a good 50%, 55% are saying yes, 45% saying no. Okay, so that's where we are. That's a little bit of information on your procedure culture. How many? We got 31 responses. Hopefully more will come in over time. You should, by the way, when you finish your survey, it should get a thank you page, a confirmation page with 2 links. One is send in another response, and the second is view results. So if you want to, go back and later, you can view results as they come in. Okay, so there's a common belief out there, at least in many of the companies that I have worked with, that the best way to improve safety and reliability is to create detailed work procedures and enforce strict compliance. So before we go challenging that, which we're going to, let's find out where that came from. So where did that belief come from? Well, the best way to say where it came from, or probably the most accurate source, is a guy named Frederick W. Taylor, F.W. Taylor, who wrote a book called Scientific Management way back in 1911, over 100 years ago. Here's a quote. "It is only through enforced standardization of methods, enforced adoption of the best implements and working conditions, and enforced cooperation that this faster work can be assured." I'm not sure about enforced cooperation. That seems like a bit of an oxymoron to me, but okay. So you may be thinking, okay, yeah, Jake, that's true. He said that and everything, but that was a long time ago. Here's the problem. There's many people today that really think that is still 110 something years later, still the best way to run an organization or run people. A group called the Academy of Management voted it the most influential management book of the entire 20th century, and they did that 20 years ago, which seems like a while ago, but not for a 100-year-old book. Think of all the books, all the insights that have come out. Stephen Covey, Peter Drucker, all the management gurus that have come out with great, wonderful ideas. Deming, they didn't think that held a candle to Frederick W. Taylor. That, I think, is kind of the root of the problem. So another thing that happened, and this was a lot more recently, the Toyota Way, the quality movement. This was focused on car factories making things efficient and reducing defects. And some people equate defects with errors. That can be a big mistake, and I can tell you why later. Deming was instrumental in this, and he said, if you can't describe what you're doing as a process, then you don't know what you're doing. That put another couple of bricks in the wall for if you can't put down what you say into a process. And I understand a process is different than a procedure in Deming's world, but still his idea was if you can't write it down, you don't know what you're doing. I would disagree vehemently with that. So if that's kind of the prevailing attitude or the prevailing approach, why doesn't this work? Why can't we proceduralize everything? So here's a quote actually from Deming. When Taylor started propounding his principles, most people, 9 out of 10 or so, did manual work, right? Moving things, making things, manufacturing, farming, mining. It looked like the photo on the left. Very, very repetitive work, not very creative, not a lot of problem solving for most people. But by 2010, when he wrote this, it had flipped. 90% of people in the workforce in America now are doing much more creative work, much more adaptive and dynamic work that's not simply following a procedure. Many people have jobs more like the one on the right, maybe not quite as nice digs for everybody, but you're problem solving, you're thinking, you're adapting. So from now on, what matters is the productivity of non-manual or knowledge workers. So that is from Peter Drucker. Here's another piece of evidence on this. The 2 authors who wrote managing the unexpected. Some people call it the Bible of high reliability organizations. They said this: you cannot write procedures to anticipate all the situations and conditions that shape people's work. It gives people the illusion they may have gotten things right, under control, and blinds them to the very real possibility that they may have gotten it wrong. So let's dive a little bit deeper into this idea. So the way I frame it is two kinds of systems. We all work with systems, including me, definitely, even in the human world. But I like to draw a distinction between mechanistic systems and adaptive systems. Here's the difference. A mechanistic system, obviously, like a machine, like many of the things that you all work on all of the time, right? It's closed and it's controllable. If anything truly goes wrong or doesn't work, you can shut the machine down, right? You can stop it. A good example is a nuclear power plant, right? If you're replacing a pump and the new pump does not look like the old pump, it doesn't match specs or something, you don't just say, well, we're going to work through it or leave it the way it is. If everything fails, you push the big red button on the wall and the entire nuclear plant shuts down in a safe state. Is it expensive? Yes. But is it safe and controllable? Yes, absolutely, right? So that's a good criteria of a mechanistic system. Mechanistic systems also are very deterministic, meaning one cause and one effect. You walk into an electrical engineer, walks into a substation, chooses the right switch, throws the handle, right, throws the switch, and certain lights go on, other lights go off, and that's all that happens. Very, very controllable and deterministic, right? It's mechanistic systems. So because of all this, because of all that control, many people in mechanistic systems, and I would say probably many of you all, equate errors with defects. And since you don't want any defects, the natural thinking is we don't want any errors. In a mechanistic system, that thinking may work. Because of this, you all, I'm betting, build what we call very robust systems, meaning systems that once you get everything the right way, you encase it in armor, or if once you write code that works the right way, you put a firewall around it so nothing can change it. And any change is bad, right? You get it the one right way you want it to work, and then you lock it in place. That's robust. That's the summary of kind of a mechanistic system. But when humans get involved, everything changes, yes? When humans get involved, and we're involved in everything, pretty much everything, we work more in adaptive systems. Human brains worked and evolved over thousands of generations to be more adaptive, not mechanistic. So instead of being like a machine, adaptive systems are much more like a living organism. It grows, it changes, it evolves, it's constantly changing, right? Instead of being closed and controllable, an adaptive system is open and dynamic. Now, that doesn't mean it's chaotic and anything goes. Look at an ecosystem, look at weather patterns. They may be unpredictable or hard to predict, but they're not chaotic either, right? Instead of having deterministic cause and effect, what word would you put on it? There's another word besides deterministic. And some of you are probably thinking about it, the people that play word games like I do, right? It's probabilistic. It's more, I hesitate to say, like quantum physics, where everything exists as a probability of something else. Drives the mechanistic people nuts. In fact, that's why Einstein said God does not play dice with the universe. He did not like the idea of probabilistic cause and effect, and that's Einstein, right? So probabilistic cause and effect is what you get in adaptive systems. Good example is, let's say you want to get a raise, right? You deserve a raise, it's come time for it, but you got to kind of argue for it. If you go take a negotiation class before you go talk to your boss about the raise, does that guarantee you're going to get a better raise? No. But probabilistically, it's on your side. And if you take a few classes, read a few books, do a few role plays, chances of you getting a better raise go up exponentially. That's probabilistic, not deterministic. Because of all this, people that work in adaptive, complex, dynamic systems have a very, very different view of errors, right? Errors are not defects to eliminate. They're not moral failures. They're signals. They're signals to adapt. They're a signal to make a course correction, right? And so because of all this, people that work in adaptive systems, primarily where humans are involved, even if it's a socio-technical system, as they call it, right? We try to build not robust systems, not systems that are impervious to change like a main battle tank or something. We try to build systems that are resilient, meaning they understand that errors and surprises are going to happen. They're inevitable, they're going to happen. And we build the system not to avoid errors, but to make it so that errors don't disable the system. That's the biggest difference between mechanistic and adaptive systems. Does that make sense? I'm hoping that makes sense. Dawn, are they able to chat in at all? I know they can't kind of voice in, but are they able to chime in on the chat thread?
Absolutely. Yep. Just use that little chat feature, just like Q&A.
Yeah, that'd be great. Folks, if you'd like to, I'd love to hear your comments on this. And I am kind of watching the chat thread out of the corner of my eye there. Would love to know your thoughts on this. And I believe actually that we have a poll coming up in just a minute. So I'd like to hear your thoughts. So feel free to chat up a storm if you want to. So I've presented these two kinds of systems as discrete, as binary, right? But they're not, obviously. Almost everybody works in a combination of mechanistic and adaptive systems, right? Almost nobody works in a purely adaptive system. There's going to be some mechanistic elements to it, and even you all that work mostly with mechanistic systems, as I've talked to maintenance and reliability engineers before, what I find is they're screaming to get more appreciation for the adaptive side, because it's way more adaptive than most people think. So it actually kind of works better not as a binary choice, which are you in, mechanistic or adaptive. It's not black and white. I think of it as a continuum or a spectrum, right? A scale of 1 to 10. Here's a couple of examples. So a factory, pretty mechanistic. You have the machines do pretty much all the work. The people are there to keep the machines running. That's much more your world. We get a little bit more adaptive. A good example might be routine lab work in a lab, mixing reagents that you've mixed 1,000 times before. You follow the recipe exactly, and that's it, right? Once we get a little bit more adaptive, a good example might be routine healthcare. You go in for a physical, they do the same things, they draw the blood, they take the blood pressure, they ask the same questions. But maybe your doctor might say, you know, that mole wasn't there the last time. No, that's not really on the list, but let's talk about that. That's being a little bit adaptive. As we get up even more to the adaptive side, I guess for you, it's going to be to that side. You're talking about a scientific experiment. I work a lot with scientists at national labs. And when things don't go right, they just don't throw out the entire experiment. They adapt, they use the data, they change the research question and see what can we discover, right? So they're constantly adapting. As we get even more to the adaptive side, I guess to that side, think about troubleshooting, right? How many of you all do troubleshooting of one kind or another? I would expect virtually all of you, right? So if that's the case, then feel free to type into the chat thread there. And I'm looking and it looks like I don't see anything in the chat thread. So maybe if somebody could just type in, just to let me know the chat thread works, that would be great. Here's my question. What's your first step in your troubleshooting process or procedure? What's the first step? Go ahead and type it in the chat thread. What's your first step to the troubleshooting process? I've heard many different answers for this, some good, some interesting, some funny, right? Many people would come out and say, well, identify what the symptom is, right? What's the problem, not what the core cause or the root cause is, but what's the symptom, the chief complaint, as we used to call them in emergency medicine. And then you go from there.
Jake,
but then when I asked,
yeah. This is Dawn again. I just wanted to let you know folks are using the question area, so I'm going to have to interject a little bit. They are responding, not using it.
Fine.
Yeah,
Got it. Thank you. I have the chat up.
Sure.
Got it.
So the question section, I will tell you what's coming in. Majority of my work is TS, transactional. Okay. I'm not sure. Observe what happens, identifying true problem, save yourself, ask the operator what happened, check if the power is on, who's creating it, why is it created. That's what we have so far.
Okay, that's great. I'm glad because I could not see any of that. I'm looking at the questions section
Mhm.
but it's not showing me anything on that. So
Yes,
interesting.
because I have you as a
Okay,
panelist. So we'll have to navigate this way. So
gotcha. Okay,
I have a couple more. The
okay, go
lock
for it.
tag out,
Mhm.
how to resolve it. If you work in nuclear power plant, it has a big difference if you work in food and beverage. Would you go
Yeah.
to the mechanistic or adaptive? Mm.
That's a great
Um,
question.
yeah. What is the procedure for it to resolve? And we're caught up. Thank you. Thanks, audience.
Got it. Thank you all for the good comments. That's some great questions. Let me give you the rest of the examples here, and then I'll move on. Troubleshooting, you got the idea. So some of you gave the first step in your troubleshooting process. There's the kicker for this. What's the seventh step in your troubleshooting process? The seventh step. I get really interesting answers from that. People rolling their eyes, people using some colorful language and telling me some fun stories. The bottom line is, a two-word phrase keeps coming up over and over and over and over if you work in adaptive systems. It depends. And if you said depends, it depends, you got a prize there, or you should get a prize there. And if you actually said it out loud, even though I can't hear you, you get double credit for that. So that's extremely cool. So yeah, it depends. Many people, expert troubleshooters, would say, well, the seventh step on my troubleshooting process, or what I do, depends on my sixth step, on my fifth step, on my fourth step. If you're an adaptive troubleshooter or work in adaptive systems, you're going to understand that that's true. But if you're a very mechanistic thinker, that's going to drive you nuts, right? You don't like that term, it depends. You want to see things written out beforehand. But the truth is, many people who work in adaptive systems can't write everything out beforehand. Couple of other examples, disaster recovery, good example of very adaptive thinking. Think about FEMA, think about state response, the initial 2 or 3 months to COVID. People might have had some disaster plans, but nobody said, in case of a worldwide pandemic that rivals the Spanish flu, followed this procedure. That didn't exist. Only now are we starting to make stuff like that up. And it's still very adaptive. And the very last one, maybe the epitome of an adaptive workplace, is in combat. You learn, you go through a lot of training. I served in the military, but I was never in combat. Obviously, you learn a lot of procedures to do, but when you get into a conflict or an engagement, it's much more about adapting and changing and evolving minute by minute and sometimes second by second. So that's kind of the spectrum of mechanistic to adaptive jobs. So now that you've got the basics, I would love to see your thoughts on this. Dawn, if you could put in the second poll, this would be great. Just drop that into the thread. And for people who are watching, just pull out your phone, scan. This is a much simpler quiz. I think it's only got one question, and it's asking you to put yourself on that scale of 1 to 10. Very simple. So I'll give a few more seconds for people to do that. And then let's see how mechanistic or adaptive is your main job. Interesting. This is fascinating because you all, I would think, are mechanical experts. You all work with primarily mechanical systems. So when I first started giving this module a couple of years ago, I assumed that the bell curve would lean really heavily towards the left. Little adaptive, lots of mechanistic. But that's not the case. Look at where the bell curve is. We have a few people saying, I'm at level 1 or level 2, and that's fine. We need people doing stuff like that. But most people who are responding so far, and I would love to see, I want to see how many people responded to the previous one. I only got 32 responses, so I would love to see some more responses here. Most people are saying number 8, so pretty heavily on the adaptive side, even working in the mechanistic industries that you do. Interesting, really interesting. So we'll come back to that a little later. So great. So what do we do with that? Now that we've got that laid out, what do we do with it? Well, what I found is that there's basically 4, you might call them work guidance tools or work guidance. I don't want to say a mode because you can use more than one at the same time, but here's what they are and where they fit. Number 1 is an explicit procedure. You all are very familiar with that. And that's on the very, very mechanistic side. And it tells you not only what to do, but how to do it. Like step 1, turn the power off. It's literally like a step-by-step procedure. You all are familiar with it. And that's bread and butter for very, very mechanistic thinking. Once we start moving a little bit more to the adaptive side, a couple of examples might be electrical engineers doing a substation switching order, which I watched done and didn't help write them, but basically worked with people that did them quite a bit. Two, mixing a chemical reagent in a lab, especially if it has noxious or toxic chemicals in it. Third might be when you're doing maintenance on an aircraft engine. I've spoken with the head of tech ops, which is the maintenance folks for a major airline, and have learned a little bit about how these folks actually do the work. So what's the second step, the second level? Once we get a little bit more to the adaptive side, we start depending a little bit more on heuristics or rules of thumb. And to me, that tells you what to do, but not how to do it. Good example might be a sign on a panel that says, de-energize before opening. Okay, great. It's saying here's something important to do, de-energize this panel, but it doesn't tell you how to do that. It kind of says you got to figure that out or go ask somebody. And if you don't know, you probably shouldn't be opening this panel. A couple of examples of rules of thumb are switch before fix. Great example from the electric utility industry. As people come up onto storm damage after a hurricane or a tornado, and the bucket trucks come up to fix it, what they used to do was start fixing every broken pole right away. Well, that's great, but that took a lot of time. What they're now starting to do is switch before fix. They'll come up and they'll go, okay, we got 20 poles down. Here's the circuit map. Is there another circuit that we can switch half the people who are out of lights? Can we get them back on now by switching to another circuit? And they'll mess around with that for a while, figure it out, work up a plan, and then say, yeah, we can get 2/3 of the people back on, boom. And within an hour, 2/3 of the 10,000 people who are out have their lights and their refrigerators back on. And then the crew spends the rest of the 2, 3, 4 days fixing. Switch before fix. But there's no procedure for that. It's adaptive every time you do it. So that's a good example. Another one, in medicine, first part of the Hippocratic Oath, first, do no harm. But it doesn't tell you how to do that. There's no procedure for that. It's just kind of a guideline. If you want to understand how an organization works, follow the money. Anybody say it? Follow the money. It's an old adage, and heuristics are beneficial because they stick around for a long time. You can use them over and over and apply them to different situations, just like that. To reduce misunderstandings, get positive confirmation. Great principle in the human performance, human reliability stuff that I do, but it doesn't tell you exactly how to do that in every case, right? In the military is a good one. If you can't get out of it, get into it, right? If you got a job ahead of you that's not pleasant at all, that you don't really want to do, don't just slog through it. Find something about that job that you want to do, or something they'll be proud of after you having done it. If you can't get out of it doing that job, get into doing that job somehow. It makes bad things go a lot easier. But it's a rule of thumb, takes practice to apply. And if you're asking, well, this is great, but does it actually apply, to very mechanistic stuff? Check out FAA Rule 91.3. If there's any pilots in the group, you'll know what it is. Bottom line, it's a rule that the FAA wrote that says to maintain the safety of the aircraft and people in your surroundings, you can break any other rule. It took a rulemaking agency to write a rule to say you can break other rules. Leave it to the FAA, but it works. Once we get even more adaptive, we're working in terms of principles, not heuristics and rules of thumb. Principles are basically how a system works, but it doesn't tell you what to do or how to do it. Good example might be electricity takes the easiest paths, plural, to ground, not path, paths, plural, to ground. Does that tell you what kind of rubber gear to wear to protect yourself? No. Does that tell you how to attach a cable, a grounding cable to a 7,000 volt line? No. Does it tell you how to ground a truck, a bucket truck, to be able to stay safe? No. It doesn't tell you what to do or how to do it. It just tells you how a system works. And principles are almost always counterintuitive or non-obvious, right? Because if they were, everybody would know them. Some of the best principles that I've heard, well, here's a couple examples. One, electricity takes the easiest paths to ground. In terms of what I do, human performance, human reliability, a good principle is When an incident happens, when something goes wrong, something blows up, somebody gets hurt, when you're trying to do a root cause analysis, here's a good principle. You can either fix the blame or you can fix the problem, but you can't do both. You can either fix the blame or fix the problem, but you have to choose one of those. Most people, many people choose fixing the blame, and they never wind up fixing the problem. When I investigate incidents or help, which I'm doing now actually with one group, I set up things from the beginning to say we're not focusing on the blame, we're focusing solely on solving the problem. Completely changes how people do investigations, or as I like to call them, event analyses. Time's a little tight, so I'm skipping ahead. Here's a really good one from high reliability organizations. The hallmark of a high reliability organization is not that it's error-free, but that errors don't disable it. Flight deck crews of aircraft carriers are one of the first original high reliability organizations. They don't try to eliminate every error. That would be crazy making. They can't. They try to build systems that are resilient so that when errors do happen, it doesn't disable the aircraft or anybody else or the ship, right? Completely different way of thinking about errors, much more adaptive. And the last level, the really high end up into the stratosphere, is tacit skill. That's the unwritten stuff. How many of you know somebody, and type this into the chat thread, Dawn, I'd be curious to see what people do, a chat thread or question. How many of you all know somebody who can do a complex job, a complex task that's very useful and very valuable, but they cannot tell you exactly how they do it? How many of you all know somebody like that? And if you are that person, just include that as a yes too. Dawn, tell me how many yeses we get, and if we get any no's, because that's an interesting question.
Oh, it's interesting. It's coming in. Absolutely, yes, 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 yes. It's just pouring in as yeses.
Yeah. So I love it because so you all know you get tacit skill, front end operators, frontline operators, the guys and the women who do the work. We get tacit skill. I've been a firefighter, I've been an EMT, I've been a military paratrooper, I've been a college professor, I've been a few other things before I did this. And in every one of those jobs, especially the high risk ones, there is always an element, a big element of tacit skill where you learn stuff that is never written down anywhere. But the people who say we have to proceduralize everything, they pretend that tacit skill doesn't exist. And it drives the rest of us nuts. So, good example of tacit skill, remember the story of Darlene, Linda, and Melissa? Darlene walked right past Melissa's isolette, wasn't even doing patient care, and something about her 30 years of experience said, what spidey sense, look again. She didn't know what she was looking for, but she found it. She wasn't following any procedure that she was able to articulate, and she saved a life, not by following procedure, but by using all the rest of these other things. So now that you got this rather complex concept, go ahead and do this scan if you wouldn't mind. Dawn, if you could, you got it, you're way ahead of me. I'd love to hear your thoughts on this. And now that we've got this idea, and it took some time to get this idea in our heads. Now let me try to give you one or two things to do about it that I've seen actually done in practice. So your work guidance tool, okay, this is a pretty simple one. What work guidance tool do you use the most? Wow, all right, 6, 8 responses. And it's always, it looks like the Windows diagram. We always get all 4 colors on it. All right, 27 responses. And I'd be curious to know, maybe if you don't mind, if you're not responding to the chats, can you let us know in the chat thread or maybe in the question thread, you know, I just don't feel like it, which is fine. I think the more the merrier for chats. But if you're having any technical problems, could you let us know that? If you can't access the QR code, or if the link won't work, or if your company computer blocks it for some reason, if you could let us know that, that would be great. 32 responses, you can see what it is. About 41% of people are saying procedures is my main thing. And for this group, I would expect that. But look at all the rest. Heuristics, 22%. Tacit skill, 25%. Fully a quarter of you use tacit skill more than anything else. And 10% use heuristics, and procedures and tacit skill for 1. So yeah, All right, so what's the alternative? What's the practical alternative to doing this? So 6 suggestions, yeah, forget that. No, there's actually 3 suggestions. We're really tight on time. And this is what I go into in some of the workshops that I teach for clients, things like that. But here's a couple of very quick suggestions. First suggestion, very important, please respect and follow required procedures, right? Just don't come out of here saying, oh, Jake told us we didn't need to follow procedures anymore. Don't do that, okay? Let's all try to stay out of trouble. So that's the first one. Second one is this. Trying to change your behavior based on what we just heard today is a big ask, even for doing it yourself. So the easiest way that I've ever found to change your thinking about something complex, to move to a new paradigm, is by changing your language. That's easy to do. You all can do it literally today, and here's how to do it. Start using these terms just when you discuss things. Don't change how you work, just change how you talk. Instead of just saying, what was I supposed to do on this job? Ask, what was the work as imagined? That's the documentation, the procedure, how it was supposed to be done. And how was the work as done? Actually, how did it get done? We call it ground truth in the military, how stuff actually gets done. Interesting aside, the nuclear industry calls that work as planned and work as performed, but that would give us WAP, and that's never going to work. So we're going to stick with WAI and WAD. So how does that work out here? Work as imagined is usually depicted as a black line, black and white, right, in writing, right? And blue line, think blue shirt, somebody who's doing the work. That's much more variable, goes up and down during the course of a job. Here's how it plays out. Work as imagined, work is done. When you're in very mechanistic mode, explicit procedures, it's pretty tight, right? What you do and what's written should be very, very close. But as we move to the more adaptive stuff, there's a bigger and bigger delta between work as written and how work actually gets done. And that's not necessarily a problem. It's just an artifact of how that kind of adaptive work happens. And once we get up to it, the tacit skill, there is no black line. There is nothing written. There's just what we've got, which is why it's really important to do things like after action reviews. I teach that in my workshops too, to really pull out and reveal the tacit skill, not just the explicit stuff. So if you would like, I'm going to drop this in. I don't know if I can do this. I'm going to give it to the organizers and they can give it to you. How about that? There is a journal article all about work as imagined and work as done. I hope it's useful for you. And here's the third and the last one, and we'll finish up with this one. This was a real team that was part of an organization that I worked with, and some of their leaders took this module and they went back and they did something amazing. They were the electrical safety team for a large government lab. This is 4,000 people at essentially a small city. So they had their own electrical team. And they were supposed to follow procedures all the time. And they tried their best, very skilled people, but they kept running into problems because the procedures conflicted or messed up or weren't written properly, were outdated. And they wound up having quite a few near misses, electrical contact near misses, almost like once a quarter, which was a big, big deal. They made the big step to say, we're going to take certain jobs and we're going to throw away the procedures. We're going to stop using the procedures which simply don't fit. And instead, we're going to create a manual for that job. And the manual for that job is going to have in manufacturer's recommendations, notes from tacit skill, notes from people who have done it before, principles, guidelines, rules of thumb, all for that job. And before we go off and do that job, we're going to go through the manual and we're going to talk. And we're going to plan out our procedure basically right before we do the job. And that's going to be the freshest, most up-to-date thing. Once they started doing that, not for all jobs, but for some, the last time I checked, they had incident-free operations, 100% reliability and no incidents for over 1,000 work days. And that's in comparison to getting a near miss, electrical near miss, once every 2 or 3 months. So that's how effective that can be. So last question, and we are tight on time. Oh, I'm gonna let you all scan this. And Dawn, if you could drop that in, perfect, that's great. And I'd love to hear your thoughts on converting unnecessary procedures, not every procedure, clearly, but some of them into manuals. And you may not call them manuals, don't get stuck on that word manual. Basically, what's your opinion on converting procedures, strict procedures, to collections of rules of thumb, principles, and tacit skill? And we'll do a quick summary and then we'll finish up. I'll take some questions after that. Okay. And let's see, I got 9 responses. I'm just going to check the other responses. 35, only 35. 9 responses. Okay, so the first one is I or others that I know have deproceduralized some tasks with good results, and that's 55, 56%. I would love to hear your story on that. If you want to, throw me an email, and we can even set up a time to talk sometime, but I'd love to get your story on that if I could. Number 2, I or others have deproceduralized some tasks, but the result were bad. Looks like only one person. Good to hear. But I'd be glad to talk with you too and see if we could give you some ideas to help. Number 3, I or others that I know want to deproceduralize some tasks, but are unsure how, and that's 40, 41%. I'm hoping this presentation gave you some practical ideas on that. Number 4, I or others would like to deproceduralize some tasks, but our company would never let us. That's a minority, 4%, 4 people, 13%. So a few, but that's an obstacle that we can overcome. And I think deproceduralizing any task is a bad idea. Fair enough. Some skeptics going, that doesn't fit in my worldview. That's okay. Healthy skepticism is absolutely good. And again, I am not suggesting remove all procedures. That would be ludicrous. That would be silly. All I'm suggesting is that a strict written procedure is not the best solution for every single job that can be done. And there are some other practical alternatives. That's all I'm suggesting. Thanks for dropping my email in there. All right, so as I am way beyond time here, sorry about that. Quick 90-second recap. Why do we keep trying to proceduralize everything? F.W. Taylor and Deming's quality movement, mostly F.W. Taylor. Why can't we do it? Why can't we proceduralize everything? Because most 21st century jobs are a lot more adaptive than they are mechanistic, including yours. What's the core insight? Procedures, the alternative procedures are heuristics, rules of thumb, principles, and tacit skill. How do we apply it? A couple of ways that we can share today. If you want more, obviously contact me. One is change your language. So start using the terms work as imagined and work as done. And 2 is engage frontline teams to start turning unnecessary procedures into adaptive manuals where it is useful, where it's appropriate. Here is a 1-page handout. I'm going to give it to the organizers. They may have already given this to you or may have already given it to you, but I hope it's helpful to you. Lots more resources on my website. And that was a whole bunch of stuff. There's a whole lot of stuff. I hope it was useful. If you liked this, it would be great if you wouldn't mind going on LinkedIn, and this is the link. I'm going to go ahead and put this in the chat thread here. If you wouldn't mind, go on LinkedIn and write a comment to it, especially if you like it. If you wouldn't mind, maybe tag myself, tag Dawn, somebody. If you know what you're doing on LinkedIn, that would be a wonderful thing to do. It shares the blessings, as it were. And if not, that's okay too. Coming up, let's see, questions. And I know we're a little bit tight on time, but Dawn, what kind of questions do we have?
Sure, yeah, great. Thank you, Jake. A lot of really, I would say, thought-provoking information. I wanted to let you know that, like, very early on in the session, one of our attendees typed in that, you know, already in the beginning, he was thinking differently, saying that he's never seen this comparison before. And yeah, so real good comment, and thank you so much. Early on, the first poll that we did, how did this audience stack up to other audiences that you've presented this content to? You know, being that this is a reliability group and you've really given this to other industries as well, what did you think about this group?
I've given this presentation for over a year now, probably 20, 30 something times. I've given it to people who operate nuclear power plants, talk about proceduralized, and maintenance and reliability engineers, not just you all, but another group. And I want to say it's not that dissimilar. I was thinking when I first did this that, oh, the mechanistic people are going to be way on, no, we need proceduralize everything. You're not. I've not found any group really that says procedures are the only way to go and nothing else works. Nuclear power plant operators realize that tacit skill is inevitable and essential, and pretty much every other group that I have too. You all lean a little bit more towards the mechanistic side, but not dramatically. Does that
Interesting.
answer your question?
Yeah, I think so. Thank you. The next one is, can this be applied to top corporate management, to that they be more adaptive and not so mechanistic?
So the approach that I take is the top management may occasionally listen to me at a presentation or something like that, and that's great. Put in touch, I'm glad to go do that. But what I find is the top management is going to listen to a certain select amount of few trusted people they have in their organization. And they usually don't tell you who they are, but the top management is going to go, well, if Beth and Tony and Michaela do it, I'm really going to listen to it. So my job is to find the Tonys, the Beths, the Michaelas, give them this, let them have a few success stories like the electrical safety team, capture those ideally in writing, and then when it's ready, share that info. Then there's real evidence of we've already been doing this. That's what I found the best way to do it.
Great advice. Thank you. Next question. Terry thinks that they may be fairly adaptive at their organization, but get mechanistic when the money dries up. Perhaps it should be the other way around. Would you like to comment on that?
No. There's a lot, man. But that's a glass of wine conversation.
Okay.
So Terry, if you want to shoot me an email, and that might be a off the record conversation over a glass of your favorite adult beverage, because there's so many questions that I'd want to ask. I don't think we have time for that here. So consider that an invitation.
Gotcha. There you go. Okay, so another interesting one. This person says that, for example, precision maintenance is about adhering to strict procedures, but, what do you think? You made a couple comments to it, but that's basically how it's worded.
So again, if the job you're doing is on the very mechanistic side, then you should be using a very strict procedure, right? When they're changing out sodium hexafluoride gas in breakers, electrical breakers, that stuff is 30,000 times more damaging to the environment than methane. That's a big deal. You want to make sure none of that leaks out. And so they have very strict procedures on doing that. Cleaning up nuclear waste, pretty strict procedures on doing that, as it should be. But not everything needs or benefits from a procedure that's that strict, especially when you're doing troubleshooting. Try to take that kind of a strict procedure and apply it to troubleshooting. You'll drive your best troubleshooters nuts and probably drive them out of your organization.
Good points. There's one here that says, do you have any experience with implementing proceduralizing in manufacturing environment on the production floor?
No, I do not. Simple, honest answer, no, I do not. But let's talk. The way I've seen it done before, and this is just the idea that I came up with, and I've done it kind of personally, but I gave it to several people at some of the organizations, client organizations I work with, and they ran with it and said, this kind of works. And so it was a resonance. It's not about me. Do I deproceduralize for you? No, but I give you the ideas and give you hopefully the inspiration to see if you can try it on your own in a very safe way. Do really small, easy micro experiments first, learn from the failures and accumulate your successes, and then move on to bigger and bigger stuff. It may take a couple of years, but doesn't everything good?
Yep, that's very true. So one final comment, and then we'll say thank you to Jake. But this is Terry again. Terry, I really suggest that you take Jake up on his offer. But he made the analogy, the World War II, he thinks that the Germans were very mechanistic and the Allies were adaptive. Another good example for your presentation.
Yeah, a very good example in when the Russians came into Afghanistan in the 1980s or something, they had plans. They had strict procedures for everything, which included bringing anti-aircraft guns. So the Russians had to bring anti-aircraft guns into Afghanistan. The Afghans, the Mujahideen, did not have any aircraft. There was nothing for them to shoot down. But because they were excellent thieves, they stole the Russians' anti-aircraft guns. The Russians had plenty of aircraft to shoot down. That's one example of where a procedure can really get you in a bad, not being adaptive can get you into a really bad place. So great example. Give me a call sometime, more examples we can trade. Thank you.
There you go. And great. Could you advance to the slide?
Oh, yeah.
That would be great. Once again, audience, I'd like to thank you for attending this best practice I can speak. Sorry, this best practice webinar with Jake. I do think he's challenged us to think a little bit differently. But the normals, really still, there's a survey at the end of this. Please don't abandon it. Tell us what you think, what your thoughts were. It's also an opportunity if you want to, get some more information or you want to talk to Jake, you can put that information in there as well. Our next webinar will be on November 3rd. It will be based on inventory. You'll see that also the details in your follow-up email. So it will have something to do with some inventory and data and all that fun stuff that you guys are doing toward the end of the year, trying to clean up and so forth. So also, if you're looking for a demo of our latest products, please, make sure you click on, the websites and poke around. So again, Excelix will be where you'll go for the playback. The recording will be posted there, and you will also receive, if you want a certificate for attending, that will be in the survey as well. So thank you, Jake. Really appreciate challenging us this way and look forward to seeing you out there in the marketplace. Everybody have a great rest of your week. Enjoy. Thank you.